Okay, good. So good morning, then afternoon, and evening where you are. So my name is Yong Baek, Technical Assistant Director working at International Hydrographic Organization. So thank you for again me to this Standard in Action seminar, and I'm very pleased to present the IHO standard activity which relates to the ISO standard. So first of all, may or may not you know about the IHO. So firstly, I'd like to introduce quickly about what is the IHO. So IHO is the recognized international authority regarding hydrography and discipline of applied science where the physical characteristics of the oceans are measured and presented. We are with the 94 members on 5 continents. The IHO set standards and coordination activity of National Hydrographic Office. So that means the old seas and oceans and navigable water are surveyed and charted. So this year is quite important to us. So the Secretariat of IHO is hosted by the Monaco government since its creation in 1921. So as I said, that this year marks the 100th century, the anniversary. The celebration will be held this month, 21st, World Hydrographic Day. So if you are interested, so we are inviting to join the virtual seminar. So hydrography is focused on the physical features of oceans and coastal area, lakes and rivers, as well as the protection of their changes over time. So surveys record many features, including the coastal topography, and bathymetry depths, and oceanographic measurement such as tides and currents. The data is used for nautical chart, but also geospatial applications and geographic information systems, GIS. So this information traditionally support the shipping, but now applies to all marine activities, economic development, security and defense, scientific research, and environment protection. So one of the IHO main tasks is to develop standards for marine species. The current digital standard used is S57, the transfer standard for digital hydrographic data. A representative publication is, as you may know, the electronic navigational chart. But we have some limitations, technical limitations. So in order to overcome that limitation with the current S57, we announced a new standard. We call it the S100 in 2010. So S100 is a framework standard that is intended for the development of digital products and services for hydrographic, maritime, and GIS communities. So it comprises multiple parts that are based on the geospatial standard built by the ISO TC 211. So S100 comprise multiple parts that are derived from the various ISO 19100 So the table on the screen, so it's with the individual part of S100 and their associated part numbers and ISO the 19100 conformance. So ISO, the base standards provide a large number of portions to developer wishing to use them for practical application. So the concept of profile provides a method of adapting the base standard so that meet the specific implementation requirements. A profile is a set of or more base standards and where applicable, and then identification of chosen clauses and classes, subsets, options, and parameters of those base standards that are necessary to accomplish a particular function. So ISO, for instance, ISO 19106 describes two levels of conformance for profiling the ISO 19103. So each part of S100 document, the level used in the conformance statement for that part. So the S100 is a settable profile of ISO TC211 standard for geographic information, and the relationship between the S100 standard core parts and the ISO based classes you can see on the screen. So I'm not going to detail the relationship on each part with the various ISO standards. So you can refer to the screen. In order to provide more the clear concept, what is S100? So I'd like to introduce some of the video clips. I'm not sure you can can you see? No?
Yes, we can see it.
Okay, now you can see it?
Yeah.
Okay, thank you. Thank you for confirmation. So this is the general introduction of the concept of S100. So the S100, so the meaning of the S100 to the maritime community is that lead to a global consistency of the products and equipment and software manufacturer implement as a 100 level. So, and also leveraging machine readable catalog for ease of updating the different product specification. An internationally recognized framework for the structure and delivery of products for the hydrographic and maritime community. So as you see on the screen is the S100 based product specification. So far we are identified from the various the stakeholders and sister organization. So the green check product specification developed has been completed as a first edition. So the first edition means is a test version in order to be a release official version. And then the other product standard is still under development by the IHO or the IALA, the authority of the lighthouse, and then IOC, and Inland ENC Harmonization Working Group, and then WMO, and then IEC, and then NATO. So there are the various organizations and groups which are developing S100 based product specification. So IHO's digital publication are basically used for navigation safety, and S57 based electronic chart is currently used, but the paper maps in the past. So in accordance with the IMO International Maritime Organization, SOLAS regulation, all international vessels must be equipped with the electronic chart display and information system. So the current S57 ENC chart is a two-dimensional information, but the S100 system will be four-dimensional, including time series such as the water level and current information. Based on the ISO 19100 series, the S100 improved the navigational safety for us and the route optimization and just-in-time, optimized loading, and automated navigation. The development of S100-based product specification is still underway, but the service is planned from 2025. This is one of the best practice from the member state. So in Norway, they are testing for the S1 or 2 product specification, which is the bathymetric data. So you can see on the screen that the giant ships could navigate in the very narrow and the shallow channel with the very precise the depth information, so they can measure when and where can navigate through this very shallow and narrow water. The other one example from the US, NOAA, is application to water level with S104 specification and also S111 surface current. So they are almost done to ready for the service from their website. So this is one of the best practice. The other best practice from the Korea, the Hydrographic Office, they are conducting a test on the various S100 base on ship on the board. So the International Hydrography Organization is developing a new digital standard based on the S100. So the S100 is based on the ISO 19103. So cooperation with the ISO TC211 is very significant for us. Thank you very much. And all.
Thank you. Thank you very much, Yong, for navigating us through this way of cooperation between ISO TC211 and IHO. There are no comments and questions, but I think we have here also Doug O'Brien, who is also co-responsible for this cooperation. I think maybe Doug, would you like to add something?
Yes, certainly. Thank you very much, Yong, for the presentation. It's very good to show people that the TC211 standards have real applications, and these real applications are nested in some of the requirements of UN agencies. For example, the UN Convention of Safety of of Life at Sea, the SOLAS Convention, which is the background to the work that is being done with all of the electronic nautical charts. The thing that you will see here, though, is one of the real strong reasons why TC211 has to look at backward compatibility. Back in the early days when we were developing the S57 standard, and I was heavily involved in IHO at that time, I think this was in 1992, the then chief of the US Coast and Geodetic Survey, and Admiral Yeager, said that it would take 60 years for the US to chart its waters up to those standards as of 1990. And we've evolved a lot since then. So it's a matter of the data is important, is valid, and must be stable. And yet we must have a way of evolving and adding to it. So this is a very big challenge to ensure that the work of standards and systems in one organization can depend on that in another. And then I'll bring in the International Electrotechnical Committee, which has a committee on ships equipment, and there's certification of ships equipment. And part of that includes these ECDIS, electronic chart display information systems. And the IEC standards depend upon the IHO standards, which depend back on the ISO standards. So as you can see, there's a very long tail here, and things do not change quickly. One last point is it's not only the UN Convention on Safety of Life at Sea, there are other UN conventions. One of the standards, S121, is the standard for maritime limits and boundaries. And that addresses the UN Convention, the UN UNCLOS, if I can spell out, Convention of the Law of the Sea. And the Convention of the Law of the Sea has a section which describes how nations record their maritime limits. That's a nation's view of its own maritime limits according to the agreed convention. But this must be deposited with the UN. And so this was for many years done on paper and went into a filing cabinet and only ever came out if something ever went to court to try and resolve a dispute. Trying to bring it in digitally so that it can actually be made available has political implications because disputes may become more visible, but it has great advantages as well. And this advantage requires that the output not only be technically readable, but it must be also, and how one of the UN representatives said, it must be possible for two lawyers to read the document and have the same understanding. That's a very difficult challenge. So I thank Yong for his input and trying to illustrate this requirement for stability of the TC211 standards.
Yes, thank you, Yong, and thank you, Doug, for your comments as well on that.